Okay, here we are back at this triangle here. Let's just get rid of all these red bits here and put some actual numbers in there. Okay, so given that triangle there, I can use Pythagoras' theorem to find what the that missing side is. So let's just do that really quickly. It's going to look like this. Okay, a squared plus b squared equals c squared, where c is a hypotenuse, in other words, 2. A little bit of rearranging and a little bit of simplifying. It gives me that side length squared is equal to 3. Therefore, the the square root of both sides, sorry I lost my train of thought there, square root of both sides is equal to, well, square root of 3 then. So that missing side length is a square root of 3. Would anybody care to guess what the square root of 3 equals as a decimal? Go ahead, guess. As a matter of fact, put it on your calculator and see what it is. That's right, folks. If you did it, you noticed that the square root of 3 is actually 1.73. And that shouldn't surprise us because we said the tangent ratio for the 60-degree angle is equal to 1.73. And if the tangent ratio is equal to the opposite side divided by the adjacent side, in this case, that would be, well, the square root of 3 divided by 1, which is simply the square root of 3, right? Here's my opposite side, here's my adjacent side. So it's equal to the square root of 3. And it so happens that equals to, or happens to equal 1.73, which you found on your calculator. Okay? So all that just to say that what your calculator tells you is just this right here for any right angled triangle. Okay? Now there's two other ratios. There's the sine ratio and the cosine ratio. Let's review what those are. So sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse. And there are the three of them together, and which brings us to our lovely, friendly little acronym to help you remember all of them. Taking the first letter of all of them, I get SOHCAHTOA, where SOH is sine is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And so SOHCAHTOA is something you tend to say a lot and write down a lot in math for this section. So fine, there you go. This is way back from Math 10. And we can use those ratios to solve for missing sides. Let's go back to our last triangle here. And the classic trigonometry problem of finding x. And of course, the super nerdy classic solution. There it is. Clearly that wouldn't work on a test. Anyways, so to find x, I can use one of those ratios. And to do that, I'm going to first of all decide which ratio to use. I have the angle 30 degrees. 2 is the hypotenuse. So I'm either going to use sine or cosine. I'm trying to find x, which is the adjacent side. Oh, look at that. I'm going to use cosine. So I'm going to set up my ratio with all the information that I have. Cosine of the angle is, which is 30, is equal to the adjacent side over the hypotenuse, in other words, x over 2. Cosine 30, I do my calculator, and then to solve for x, I'm just going to multiply both sides by 2. In other words, what I'm doing here is just kind of cross multiplying, right? X times 1 is x, and 2 times cos 30 is my answer. And on your calculator, you get, big surprise, 1.73. Sounds familiar, right? Because it's the same triangle we did last time. It's the same side length. Okay? And I could just as easily use the same method to find my other missing side. Let's call it y here. Okay? And it should be 1. But let's just do it just to make sure. Okay, well, we have a lot of options here because we know so much about this triangle. I know this up here is 60 degrees. I know this side down here is 1.73. What do you want to use? You have to kind of make a decision. So let's use the 30 degrees again. I'm trying to find that y, which is the opposite side. So I'm either going to use sine or tangent. What other piece of information do you want to use? You know what? You can pick whatever you want. I'm going to choose 2. So I'm going to use 2. That's a hypotenuse. So that therefore I have to use sine in that example. So set up the ratio like last time. And also like last time, cross multiply. You get y is equal to 2 times sine 30, which just happens to be 1. Okay? And we knew that was going to happen anyways. Okay, one more video and that's it, I promise. Skip to it, and there'll be a homework assignment at the end of that one.